testing null versus alternate hypothesis when there are two groups. So now we have this, when you have the overall set of data from both the drugs, is to calculate the mean value of all the data from both the drugs. And then calculate the distance between each observation on the mean, like this. The first circle, how far it is from the mean. The second green circle, the third green circle. You calculate the distances between each observation and the mean. First, you take the overall data, do the mean, and see the differences of each of this. And similarly, you do for drug D also. Now, why are we doing this? And compare those to the distances calculated from individual means for drugs C and D. What do I mean by that? See, the overall has a mean like this and individuals have a mean like this. Now, individuals, you see this is the difference. And also for the drug B, this is the difference of the first, second, and third. Why did we do this? These distances around the single mean represents null hypothesis that there is no difference. If there are differences, then the data will show more. But this is actually the overall mean we are taking and comparing the distance of all the samples to test whether there is a significant difference or not for the null hypothesis. And these distances around two separate means represent the alternate hypothesis. But then understand that there is overall mean that we take and we find the distances from the individual points, and we also see the distances of the two different drugs, calculate the averages separately and then calculate the distances from that average of these individual averages. And this means the alternate hypothesis that there is a difference in recovery times of drugs C and D. If the distances around these two means are much shorter than the distances around the single mean, then that suggests that using two means to summarize the data makes more sense than using one. So we will reject the null hypothesis. Alternatively, if the data looked something like this and the distances from the single mean were not dramatically different from the distances around the separate means, then we would suggest that the differences between the two means only reflects the random things that we cannot account for. For example, it could be subtle difference in means due to this one guy getting less exercise than anyone else. If he had exercised just a little bit more, he might have recovered from the illness faster. We would no longer see a difference between the two means. In that case, we will fail to reject the null hypothesis.